All right, our last example in section 13.2, we're going to talk about how we can actually apply this idea to a real-world concept, even a business concept, where we can find the maximum or minimum of something. So maybe we want to maximize our revenue, or we want to maximize our profit, or maybe we want to minimize our cost. We can find those maximums and minimums by using our derivative, kind of the same way we've been doing with just regular functions. If you look at example number 4, it says a small company, manufactures and sells bicycles. The production manager has determined that the cost and demand functions for Q, as long as Q is greater than or equal to 0 bikes per week, is given by these functions, where P is the price per bicycle. So we have the price per bicycle here, and we have the cost depending on how many bicycles we're selling. All right, the first part of this question asks us to find the maximum revenue. We need to then figure out what the revenue equation is so that we can find the maximum revenue using my derivative and making sure that the derivative goes from positive to negative, right? Because that tells me I have a maximum there. To find the revenue function, remember revenue is always Q times P or P times Q. So we have our P, which is our 90 minus Q, times Q. Q times P to give us our revenue function. I can distribute that Q and simplify my revenue function as 90Q minus Q squared. Now this is just my revenue function. I want to find the maximum of this function, right? I want to find where my derivative changes from positive to negative so I can find that maximum value to maximize my revenue. So let's go ahead and follow the steps that we've been following, where we find the derivative first. So the derivative of 90Q minus Q squared would be 90 minus 2Q. This is my derivative of my revenue. This is my rate at which my revenue is changing, or another word we use is marginal revenue, right? We now need to find our critical numbers, where we can take that derivative and set it equal to 0, or does not exist, but 0 in this case. We can go ahead and solve this equation by adding the 2Q to both sides and dividing by Q. And I ended up getting Q equals 45. Remember, Q is the number of bicycles I sell per week, so it looks like I have a critical number at 45. Now, it's important that we test because I don't want to accidentally find a critical number at 45 and then my derivative changes from negative to positive and I just accidentally found a minimum and not a maximum. I want to make sure that I maximize my revenue, not minimize it. So we still have to do our sign chart and we still have to test numbers before 45 and after 45 in our derivative to make sure that our derivative changes from positive to negative and not the other way around. So I plugged in 44 to my derivative and I plugged in 46 into my derivative, my marginal revenue equation. When I did that, I got a positive and then a negative. So that means my function is increasing and then decreasing. That's perfect because if it's increasing and then decreasing, I know that there's a relative maximum at Q equals 45. Now remember that was a point. And so if we want to figure out what the maximum revenue is, well, the maximum revenue happens when I sell 45 bikes. But how would I figure out what my actual revenue is when I sell 45 bikes? Well, that means I've got to go back up to my revenue equation and I've got to plug in 45 so I can figure out what my actual revenue is when it's the highest. So I'm going to plug in 45 into my revenue equation and I ended up getting 2,025. So I can say, when I sell 45 bikes per week, my maximum revenue will be $2,025. Let's look at part B. Part B says we want to maximize our weekly profit. So now we want to find where the profit changes, the profit's derivative, I should say, changes from positive to negative. But before I can do that, I've got to come up with a profit equation. Remember, profit is my revenue minus my cost. The profit is the amount that's going in my pocket. So I need to find a revenue equation minus a cost equation. Well, back in part A, didn't we say that the revenue equation was my 90Q minus Q squared? And up in the problem, didn't it tell me that my cost function was the 10 plus 5Q plus 1 over 60Q cubed? Making sure that I put it in parentheses so that I can distribute the negative through. I'm going to combine like terms. And I end up getting a profit equation of negative 160Q cubed minus Q squared plus 85Q minus 10. Now this is my profit equation. I can figure out what my profit is anytime I know how many bikes I sell per week. But I don't necessarily want to figure out what the profit is. I want to figure out when my profit is the maximum. So I want to find the derivative of my profit and see where it changes from positive to negative. So pause the video, find the derivative of this profit equation, or find me the marginal profit. When I found the derivative, I got negative 3 over 60q squared minus 2q plus 85. I reduced that a little bit and got negative 1 over 20q squared minus 2q plus 85. This is the derivative of profit. This is my marginal profit. This is the rate at which the profit is changing, right? All different interpretations for the same thing. What we want to do then is we want to figure out where this derivative equals 0. So I'm going to set it equal to 0, and then I need to solve this. You may notice that it's a quadratic equation. I have my variable squared here, but if you look at the coefficients, it looks like one of them is a fraction. And if you don't want to have to work with fractions, what we can do is we can clear fractions by multiplying every single term in there by the common denominator, which in this case would be 20. When I multiply every single term by 20, 20 times 0 is 0. 20 times negative 1 over 20 is negative 1. 20 times negative 2 is negative 40. And 20 times 85 is 1700. That might be a little bit better, but now we're going to have to still solve this quadratic equation. You can try to factor it, but I'm not sure that it does factor. So again, you have two options. You can either use the quadratic formula, where you can choose a as negative 1, b as negative 40, and c as positive 1700. Or you can use your calculator, and I've shown you a couple different videos of how you can use your calculator to solve and find the zeros. When I did that, I ended up getting a 0 at negative 65.8 and a 0 at 25.8. Now, we're talking about the number of bikes, and remember Q means the number of bikes we sell per week. It really wouldn't make sense for us to sell negative 75 bikes. That's why that one's crossed off. But it would make sense for us to sell between 25 and 26 bikes per week, 25.8. So there's my critical number, but let's make sure we've found a maximum and not a minimum in our profit. So I'm going to take a number before 25.8. You can choose 25 if you'd like to. I'm going to choose a number bigger than 25.8. You can choose 26. Plug that into your derivative, remember. That would be the blue equation. And let's figure out if that derivative is positive or negative. So pause the video, try it. Make sure that you know how to do this all by yourself without just trusting me all the time, so that you know how to do it when you're doing your homework and your exam. All right, when I plugged in a 25, I got a positive derivative. When I plugged in 26, I got a negative derivative. That means my original function, my profit, is increasing and then decreasing. That means 25.8 is a maximum. Now, we obviously can't sell a 0.8 of a bike. I guess maybe you could do like the tires and something, but we need to probably either sell 25 or 26. So let's go ahead and take 25 and actually plug it into my profit function, my original profit function. That's the pink. And then let's plug in 26 to my profit function and figure out which one's actually going to give me the most profit. If you look, we're actually going to get the most profit at 26 bikes. So if we have to round to a whole number, 26 bikes per week is going to give me my maximum profit of $1,231.07. All right, let's do one more here. Look at C. C says find the price that the company should charge to realize the maximum profit. Well, we know then that the maximum profit is going to happen when we sell our 26 bikes, right? And so that means Q equals 26. We've got to figure out what price we want to charge. Now be careful with all these different P's. The P in the last part of the problem was profit, not price. Remember, if you go back to the very beginning of the problem, this equation represented the price of my bike. So if the price function is 90 minus Q, then I can now go back down here and say if the price function is 90 minus Q, and I know that I have to sell 26 bikes per week, I know that Q has to equal 25 for me to get a maximum profit, I can use that, plug it into my price equation, and I can figure out what 90 minus 26 is, and say that I should be selling the bikes for $64 per bike. I need to make sure that I sell 26 bikes per week, and I need to sell them for about $64 per bike so that I can maximize my profit. Kind of cool to be able to use the derivatives to figure out when you're going to get the most money, right? All right, make sure you practice all of those different steps, especially the ones with the calculators and plugging in your values into your derivatives and your original function, making sure you know how to get the correct numbers, and let me know if you have any questions.